CodeWithBK. So in this video, I'm going to solve the question number of ISC 2012 Computer Science Practical Paper, and I'm going to follow my usual strategy. I'll read the question, clear all my doubts, and then I'm going to prepare an outline, and then I'm going to code this. So question 1 says, a prime palindrome integer is a positive integer without leading zeros, which is prime as well as a palindrome. Okay, given two positive integers m and n, where m is less than n, write a program to determine how many prime palindrome integers are there in the range between m and n and output them. Okay, the input contains two positive integers m and n, where m is less than 3000 and n is less than 3000. Display the number of prime palindrome integers and specify in the specified range along with their values. Okay, so the example one is m is starting with 100 and then n is 1000. This is the output, and for m 100 and n 5000, it is out of range because n has to be less than 3000. The question is pretty clear. So one more thing you can do is you can add a check that m is always less than n, because this has to be followed. So make sure that you add it, even if it is not in the set of the sample cases, but it says where m is less than n, you should add it. It's a simple line of code that you need to add, and then I guess this and this you can check, and then we can iterate the set of values from n to n inclusive, I guess. So, okay, so it has to be inclusive. So and also you can then check each of the values for prime palindrome. The question is clear to me, so I'm going to get started. So okay, the main method ARGS. So I'm going to use a scanner class for input. Import the scanner class of input to java.ut scanner. Okay, and create scanner object to read std scanner scanner system. So I always tend to close the scanner whenever I open it, and whatever be the input is, I'm going to do in between this. So first, I guess we need to read the value of m and then n. Okay, and as I always tell you, that your output and input in the program should be as close as possible to that given in this question. So I'm going to prompt something like this: m is equal to, and I'm going to prompt n is equal to, and I'm going to proceed. So system dot out dot print ln. So I'm going to prompt for m is equals to, and then int m is equals to scanner dot next int. Okay, similarly, okay, I just ask for the value of m, and then read the value of m. Ask for the value of n, read the value of n. Okay, so these are the two inputs that you need to take from the user, and I don't think there's anything else that is to be input. Yes. Okay, now we have to check for a prime palindrome method that checks if this value is a prime palindrome. It is prime palindrome n. So I will have to write two other methods as well. One of which is going to check if this given number is prime or not, and the other one will check if this is palindrome. Check this value is prime number. So static boolean is prime. So I have a standard technique of checking if an integer is prime or not. So first I do if this is 1, return false. If n is equal to 1, return false. this is to return true. If n is equals to return, so even because maybe it is that we don't have 2 or 3, no, we can have it. Okay, so this is my standard technique. Now you may question that why do I have separate cases for n equals to 1 and 2, because 1 is neither prime nor composite. So for if the value is 1, it is not prime, so I return false. If the value is 2, I return true, and 2 is the only even prime number. So for all other even values, return false. Okay, if n% 2 is equals to 0, I return false. So I eliminate half the possible values in any given range. Okay, then check by iterating. So for int I is equals to 3, so whatever with the value here will start from 3 onwards. Okay, and then I is less than equal to math dot sqrt of n. Okay, now this you may question that why am I going till less than square root of n and not till n, because any value that can completely divide n cannot be greater than its square root. So this is something that you can discuss among yourselves and you can find it out. It's a standard technique. Okay, then I move ahead, and if I divides n completely, return false. If n% I is equals to 0, return false. Okay, and if none of these I values divide n completely, I'm going to return true. So in this case, this value is prime. So my method is prime is complete. Now I'm going to check for palindrome. Okay, so static boolean is palindrome. Okay, and have value in. So convert this into string. The simple method is string n string o is equals to blank plus n. Okay, and return true in the end, or I'll do that little disclose this. Okay, so I'm doing this because for me it is easier to check if this is a string, because if you have to compare the first and the last digit of an integer, it can be a little more tricky. But if you have to compare the first and the last digit, that is the first and the last character of a string, it is a lot more easier. So compare for int I is equals to 0. I traverse the first half of the string, which is this string form of this integer. So in this first half, I'm going to compare all the corresponding values of the first half to the second half. That is the first character to the last character, the second character to the second last character, and so on. And if there is any mismatch, I'm going to return false. I is less than n string dot length HIO length by 2 and I plus plus. Check if the characters match. Okay, so if n string dot char at I is not equal to n string dot char at n string dot length minus 1 minus I, return false, else return true. Okay, so we are comparing. So if you follow this loop, we started comparing the first character and the last character of the string, then we compare the second character to the second last character of the string, and so on till we go till the middle of the string. Dot char at I is not equal to dot char dot length minus 1 minus I. Okay, return false. And this is prime palindrome. Return is palindrome and is prime. Okay, is palindrome and is prime. Then I need to check the values here. Okay, so the output is we have to print the prime palindrome integers and then we have to print the frequency. Okay, so I will check the frequency. frequency, sorry, int frequency is equal to 0. Okay, and for int I is equals to m, I is less than equal to less than equal to n I plus plus. Okay, we did not check for the valid range, so we are going to check for valid range first. Validate for values m, and if m is greater than or equal to 3000, because m has to be less than 3000, right? M has to be less than 3000, so it cannot be greater than or equal to. So print error system dot print len, what does it say? Out of range, out of range. Oh. And I turn. Okay, similarly I'll add this. I can add a separate if statement where I check for n, or I can do it in the same if by adding an or condition to both. So if either m is greater than or equal to 3000 or n is greater than or equal to 3000, in either cases we print out of range. Okay, then add a check for m is less than n. So we do not have a test case where m is not less than n, but since it is given here, I say it added. It's a simple check. If m is greater than equal to n, right? So because m has to be less than n, so if m is greater than equal to m, I'm going to print out of range. Okay, and then I have the frequency. Okay, check if this is valid prime palindrome. Okay, if so, I'll just copy this method's name. It's prime palindrome. It's prime palindrome I. Okay, so in this case I'm going to print this. Okay, now there is one more thing, that what if there are no prime palindromes in the given range? So do you print this prompt and show nothing and then show the frequency as 0, or you just print there are no prime palindrome integers in this given range? So what I do is I count the frequency first. So I do frequency plus plus. Okay, then I create an array to store the values. Okay, so int pp is equals to new int frequency. Okay, then if the so I do not need the array if the frequency is 0. So if frequency is 0, I show message and terminate. That is, if frequency is equal to 0, print system.out.println. So this is a case which has not been given, so you'll have to assume something, and it is right to assume because there is no point of printing this prompt and then showing no values and then showing the frequency of the prime palindrome integers as 0, or simply print frequency, simply print frequency of prime palindrome integers is 0. Okay, terminate. Okay, so if the frequency is 0, I will just print frequency of prime palindrome integers 0. Okay, else I'll create an array and I'll copy this, copy all values. So I take an index is equals to 0. I copy this loop again, and if it is prime, then I add to prime pp of index plus plus is equals to I. Okay, and I'm going to print the values. Okay, so the my reason of taking an array and storing all these prime palindromes into this array is because I do not want this extra comma in the end. So otherwise, if I check for prime palindrome, simply check for prime palindrome and directly print, so I'll have an extra comma in the end. I'll show you how. Okay, so let me just show you how without this. So show message out dot ln. The prime palindrome integers are the prime palindrome integers. Okay, and I'm going to simply print. So I'll not use this array. I'm going to simply print system.out.print I plus a comma. Okay, and I send then the frequency. Excuse me. Okay, so this should be it. Okay, so let's just test this out. So Java C 2012 practical question 1. Okay, hopefully no error. Oh, there is an error. What does it say? Incompatible types. Oh. Boolean. Okay, should work now. So m is equals to 1000, n is equals to 400,000. So you see, okay, I'll just shift it a little. Okay, I did not touch it because the values are correct here. You can see. So 10113115118211911353 and so on. So I will do just one more change. Okay, you see the output is exactly the way it is, and but I have this extra comma, so it is not a big deal. Your output is correct. It's just the formatting is a little different from what it is given in the question. It does not matter much. So even if you get this output, this is perfectly fine. But if you want perfection and you want to remove this, so what you can do is now this array comes into play. So I'm going to not print it right now. I'm just going to store it in this array, not change the line, and print the values separately. So what I do is point copying, I guess 0 I is less than pp dot length I plus plus. If this is not the last, so print the value first, print the value. So I'll do system.out.print pp of I and I will print a comma if this is not the last value, print comma. Okay, if I is less than pp dot length minus 1 system.out.print a comma, and finally change the line. So you will see that extra comma at the end disappears. It's not a lot of work to remove that comma. but if you want, because you might want to get your output very close, so I have 100 and 1000. So you see that comma is gone, the output is exactly the same now, right? I'll test another case, 100 and 5000 out of range. I'll test another case, 33,000 and 3100 out of range. I'll check another thing. I'll have 100 and 98. See, m to n, and I have m is supposed to be less than n, so I'm adding this test case as well. It is not given in one of the sample cases, but you should add it. I'll clear again and I'll add one more test case. Say I start with 1 and I go till all the way to 2999. So these are the all prime values. So you can see 2, 3, 5, 7, 11. Okay. So this was the code to my this was my code to the problem, and I hope this was helpful. So if you found this helpful and learning, so please do like this video and subscribe to my channel for more such videos. And thank you so much for watching.